Hi, everyone. Thanks for being here today. I'm very excited to talk to you about, to kick off this workshop. We have quite a few awesome speakers today with us who will be talking about a lot of interesting topics related to large language models. And I'm going to tell you a little about, a bunch of things that we've been thinking about for quite some time now. And the general topic that I like to talk about that I hope that will lay the foundation for what you'll hear for the rest of the day is what we call KnowledgeOps. And I'm hoping to convince you by the end of this talk that KnowledgeOps is something that you should start talking about and start telling people about, and just add it to your vocabulary. So I asked ChatGPT what KnowledgeOps means, and it told me a very long thing, but one sentence was the management and optimization of an organization's knowledge, assets, and processes. So if you look at that definition, you might say, well, that's been around for a while, and that's true. But let's get into it a little to see what this actually means. So if you look at this definition, there are two terms that are interesting: assets, knowledge assets, and processes. If you think about it, what does knowledge assets mean for us? For example, it could be data, it could be code, it could be documentation, it could be other types of things. So generally speaking, anything that we externalize and store somewhere that we can use it. So part of KnowledgeOps is managing these artifacts in a way that is reusable, it is easy to collaborate on, etc., etc. And importantly, it doesn't say that this externalization is easy, because a lot of the time when you externalize information like the data, code, etc., as much as we try, it doesn't always have all the contextual information. It's just not possible to capture all the contextual information. Therefore, we need proper processes around these artifacts to make sure that they are reusable, they are possible to collaborate on. So what are some of these processes? For example, we have to have processes around communication, right? So many of you who do Agile, you're familiar with rituals and ceremonies that we do, that we bring people together and make them talk to each other. We make them to talk to each other in specific ways, right? Then we have patterns and processes around project management, like how do we take in projects, how do we split it up, and how do we execute on it? And generally speaking, we have processes around collaboration, like what are the steps that we are going to go through to make sure that everything that we're building has everyone's input and strengths and a skill set taken into account, so that we are more efficient. So I'm not saying anything groundbreaking, so you all are very familiar with this, and so hopefully at this point we should be relatively convinced that KnowledgeOps is a thing that we've been doing for a while. So what's new about what I'm talking about? So let's go forward. I want to go a little deeper into one specific example of KnowledgeOps called, DevOps. So you've seen this. It's been around for almost 15 years now. And many of us have engaged in it. Many of us have used it in our day-to-day work. So we should be pretty familiar with it. So let's go a little deeper. So the formal definition of DevOps is a set of practices, tools, and cultural philosophy that helps you develop faster. There's a lot of information, but ultimately, what does this mean? It means that it's a set of processes and tools that allow us to think faster and experiment faster. So I think this part is the most important part for me. Like the chances of failure significantly reduces in teams that adopt DevOps. And if you think about it, the reason that that's happening is that we are able to make smaller changes in our system, see what happens, and then keep repeating that, right? So the ability to fail safely significantly increases when we adopt DevOps practices. So specifically in all of the practices that exist around DevOps, I'm interested in what we call shifting left, or CI/CD. So usually when we are building software, we start from the beginning where we sit down and plan a bunch of things, then we build, Then we get to the annoying parts of testing and quality assurance and performance. So the idea of DevOps, very fundamentally, is to bring all of these to the beginning and provide tools that mostly automate these things so that you don't have to worry about it. It is consistent across the board. It is repeatable. So you can focus on, designing and building and all of those things, and all of the other things that might lead to failure are taken care of very early on. So what are some of the tools that we use for this kind of process? If you look at the product development lifecycle, it usually starts by, we do a bunch of discovery, we plan what we should build, we build it, we test it, we deploy it, we operationalize it so that users can interact with it, we observe their interactions, we collect feedback about their interactions. Based on the feedback, we discover new things and we repeat that. And throughout this process, we communicate with our teammates and collaborate. So, you probably are all familiar with many of these tools that we've been using throughout this life cycle. But the important problem is that, as successful as DevOps has been, it has a significant single point of failure, because we've automated a lot of these processes, but the step where we are discovering things and planning things is very manual. So as much as we have made progress, if the person who is interpreting the results and designing the experiments is not doing a good job, it doesn't matter how many experiments and how fast they're doing it, right? So the chances that they land on a good experiment will increase with DevOps and automation, but if they're just making bad decisions, they're making bad decisions. So there's a single point of failure in this infinity loop. And this becomes even harder and more complex to deal with when we are dealing with products that have data and models involved in it. So, in the past, 7, 8 years, maybe, definitely past 5, 6 years, people have started talking about MLOps and model ops. For those of you who don't remember what was before generative AI and what was before NFTs, MLOps was the hot topic of the day. All the investors were super excited about it. There were like so many fundraising announcements about it, et cetera, et cetera. So for a while, we got really excited about model ops. And it was interesting because, we were able to start building tools that help us in a mostly automated way, carry out experiments and monitor data and models involved in our software. So that was very good. We had tools that allowed us to build better softwares and do it in a way that problems would surface much earlier in the process so that we can fix them before they're too expensive. So sort of like effectively what was happening there was that the build process was unfolded into its components, which is, data and model handling, right? So sort of the infinity loop became a double infinity loop with explicit, tools that handle this part, which is data and model part. But we did not solve this problem. Like still, the manual steps of dealing with data and model was largely dealt with, but still humans were involved in interpreting the results and designing what we should do. And the way they do it is that they talk to each other. They look at documents like, scientific papers, internal documentation. They look at the constraints that exist throughout the process and make decisions about what things to try, right? So that is step, that point of failure still existed in our systems and the way we worked. So that's why in the past 3 years, all of a sudden, a lot of interesting things started happening with generative AI, enabling us to build tools that went beyond the capabilities of our, older tools. I will take a quick look at those in a minute, but essentially it allowed us to shift further left into the knowledge-intensive steps. So what does that mean? It means that we are starting to see tools that are enabling us to shift further left into the steps that are exploration, planning, and coding. And I'm saying that these are going to be automated because at some point they will be, But at least we are seeing tools that are significantly augmenting our ability to explore, plan, and code our experiments, right? And that's a thing that has been traditionally very knowledge intensive, very expert intensive. But we're starting to see tools that are allowing us to go further left. So what does that look like? It looks like this, because we can start unfolding the build process as well. Like, we can start thinking about tools that can help us interpret results, generate hypotheses. You know, start thinking about tools that can help us explore, like diverge and see what all the options are. And we can start thinking about tools that can help us negotiate with our teammates and, you know, the constraints of our businesses to come up with plans. So let's take a closer look at this. But my prediction is that, you know, before that, my prediction is that CI/CD is going to turn into CE/CI/CD, where the CE part is the continuous exploration. So instead of just, you know, having these two parts, continuous integration and continuous delivery, being largely automated and streamlined, you're going to even have the ability to continuously generate hypotheses, experiment with those hypotheses, integrate the results into our systems, deliver them to the user, measure the result, and design new experiments. So eventually in an automated way, but at least in short term in a significantly augmented way. So why am I saying this? Why do I think that this is going to happen? So if you look at the tools that existed in the space of, you know, knowledge intensive work, you know, traditionally we used tools that involved manual documentation of knowledge or manual interactions with coworkers. And in the past, probably 6 or 7 years, we are starting to see tools that are a little better versions of these, but it's still, you know, building knowledge is pretty much manual in them. In the past 5 years or so, we have seen tools that are very good at semantic search and retrieval of information that is very specialized. Like, these are some of the platforms that you might have seen. But all of a sudden, in the past 2 years, you're starting to see generative copilots. Like, you know, GitHub Copilot was the first one. I'm sure all of you have played with ChatGPT. That's why you're here. But, you know, this trend of combining this generative copilots and retrieval systems is already happening. And the next step is really combining these with reasoning and other types of systems that we use in the process of thinking. So sort of my prediction is that, you know, in the next 2 years, we are going to see a lot of tools that are in the overlap of these and significant, you know, other components that enable us to reason and model the world around us. And therefore, you know, it will allow us for, you know, significant augmentation in how we think and experiment. So what do we need to be able to think and experiment? Well, we need language skills, we need reasoning skills, and we need memory skills. And large language models, amazingly, are enabling us to do almost all of these. Sorry, I have to plug in my laptop. I'm back. So language models are, you know, enabling us to do all of these activities. Maybe not alone, like they need to be interfaced with other tools, but, well, they can do that too, because language models are not only good at natural language, but they're also good at formal language. So they can produce code that interacts with other systems as well. So let's dig a little deeper into each of these. So why do tools for thinking need language skills? Well, first of all, they have to interpret what the user is saying, go do something, come back and explain the results to the user, right? Like, that's the most natural mode of, you know, intellectual interactions that we do. And if you can do that with a machine, you know, that's the most natural way to do it. I'm going to tell you something, you go ahead and do a bunch of computation, come back and tell me the result. But the very non-intuitive consequence of language skills is also facilitating human-human communication. And that's very interesting. Like, you know, I didn't really think about this until probably a few months ago, because a lot of the people that we've been talking to in our customer base, you know, they talked about failure modes in their projects and not able to deliver. But now I'm thinking the reason is that they cannot articulate a problem that they're trying to solve. For example, they have a vague idea, they cannot articulate it to their engineering team to develop it, right? Or they articulate it, but in a way that the engineering team misunderstands, or any sort of a stakeholder that they're dealing with. So, and we've seen, for example, ChatGPT being really good at this. Like a lot of the time, I'm already doing this all the time. Like I write something, go to ChatGPT, ask it to rewrite it, and then send that to somebody else because it's just better than I am at articulating things. I can even say, articulate this in an excited way, right? So the ability of language models to articulate is very, very interesting. And if combined with their ability to reason and keep track of information, then it becomes a very interesting powerhouse in human-human communication as well. So the memory skills, why is that important? Because, you know, we want these machines that we use to think, to keep track of all the information that we provide to them. And we want them to know our context so that we don't have to repeat it every time. And of course, you know, if we're using these in the context of an organization, we want them to be able to integrate into various types of knowledge bases that already exist in the enterprise. So the combination of large language models and information retrieval systems are giving our, you know, thinking machines the ability to have memory and keep track of things. And finally, we need them to have the ability to reason. The idea is that, you know, the user provides some instruction, some intent, some desire. Like they might say, I want to figure out how to design a machine learning pipeline to detect cancer, right? So the system has to interpret that through the language skills, turn it into some other type of you know, reasoning plan. For example, it can say, these are the steps that we need to reason about this, and these are the actions that we need to take. For example, if you want to detect cancer, so I need to know what kind of cancer, what kind of data is necessary, and then an action could be, well, search a few options and show me the results, right? So it has to be able to reason through processes like that and come up with plans. It needs to be able to convert some of these plans into formal language, like to talk to other types of system, like a calculator, like Wolfram Alpha, like a SQL database, etc. Right? And then eventually, it should be able to get the results of those actions and combine them with the reasoning that it has done into a synthesized version of what it will present to the user. So I know these are a little high level, but hopefully we can, you know, discuss them a bit. But I'm going to give you a concrete example because we're using all the above to build an interesting product, hopefully interesting for you. So essentially, we are using the language skills of large language models, their reasoning skills, and their ability to interface with you know, memory and knowledge bases. And we have created a system that you can talk to, and within 15 minutes, it can take you from a vague idea, like what I said. I want to design a system to use machine learning to detect cancer. And in 15 minutes, it will generate a Jupyter notebook with the initial implementation of that for you. And, you know, that's powerful, right? Like before, you had to sit down and think about it and Google and, you know, open a bunch of papers and a bunch of documentation to even get to the point where you can even ask your question, is this worth my time to explore this? But now within 15 minutes, we can give the user the ability to see a concrete action plan, a concrete implementation for their idea. We also have a very large global community, which means that, you know, then they can interact with them to further validate it and, you know, take the implementation to next stages, et cetera, et cetera. But, you know, this is amazing. Like until half a year ago, this was completely impossible. But today with large language models, we can easily do this. I mean, not easily, but we can do this. So I want to wrap up. You know, this was supposed to be a quick talk, and I'm hoping that we can do some discussion. But, you know, I try to evolve this definition of knowledge ops throughout this presentation. I started from the formal definition, nice and vague, but hopefully by now you see the value of knowledge ops. So knowledge ops are processes, tools, and automation that we are creating, at least augmentation that we are creating, to get to a point where everybody feels empowered to try new ideas that they have, right? So for example, if somebody wants to figure out, is this crazy idea that I have even possible and feasible to be implemented? It shouldn't, take them weeks. That there shouldn't be that huge barrier of entry to even try to explore that idea. And knowledge ops is a set of tools and mindsets that will enable everybody to try their craziest ideas. And that's what we are trying to build at Aggregate Intellect too, through the tool that we're building, but also through the company actions that we've been establishing. So on that note, I'm going to wrap up because I want to take a few questions so that we can discuss this a bit, because I'm sure a lot of this is new and you haven't been thinking about it this way. But I also tried in this presentation to set a bit of a precedent for what we are going to see for the rest of the day. For example, the next presentation is going to talk about how large language models integrate into existing products. A presentation later today will talk about how large language models learn how to use tools. The last presentation today will be about how large language models are going to be used in the commercial settings, or how we can optimize them to do various types of tasks. So there are a lot of interesting talks today, and hopefully, I try to keep this high level enough and tease all of those topics and put it all in context to see why you should pay attention to all of the talks that are going to happen today.